Hi, Math 1 classes. Mr. Bruns here. Today we are going to get a brief introduction into exponential functions. Exponential functions, we've talked about these a little bit earlier on in the year, but we're going to really kind of dive into them. Exponential functions are anything that look like this. Anything of the form y equals a times b to the x. B ends up being our multiplier. If you remember, we can make some connections between what we did with sequences. We talked about arithmetic and geometric sequences, and we'll find that exponential functions that look like this are connected to those geometric sequences. B is like our multiplier. How much are we growing by, or possibly how much are we reducing or decaying by? A right here, that's our starting value. That ends up being our y-intercept. And I want to make just some quick connections between an exponential function, y equals a times b to the x, and then our standard slope-intercept linear equation right there, y equals mx plus b. Unfortunately, just the way that our book writes things out, our book uses a times b to the x. This b over here that we know to be the y-intercept, or the starting value, is not the same as that b right there. So unfortunately, they decided to confuse us, and they're going to use different letters to represent our starting value. Remember, our y-intercept happened when x is 0. Our y value will be, well, y equals 0 plus b. Our y value is b. So over here, our y-intercept, or our starting value, if we let x equals 0, this becomes y equals a times b to the 0. And if you remember, anything to the 0 power is just 1, so your y value is just a. So for an exponential function, that starting value, that y-intercept, is this number in front, not the thing that's being raised to the x power. Okay? Graphically, the types of graphs that we see off of exponential functions typically are of this form right here. It's something that grows up like that. Off to the left, we have this horizontal asymptote. We kind of touched on that earlier, where there's this invisible line that we never actually quite touch. In the case of these exponential functions, we never quite touch this line, y equals 0 off to the left. However, we just grow and grow and grow. We are going to cross the y-axis here at a y value of a. That would be the point 0 comma a, whatever this a is that's sitting in front of our b to the a. Okay? Sometimes our exponential functions actually decrease. And if you recall, when we dealt with the bouncing balls, where we measured their rebound ratio, that rebound ratio, that multiplier, that was our b value. When we found that that was less than 1, then our exponential functions decreased like this. And in this case, we still have that horizontal asymptote. It's just we're approaching that horizontal asymptote. We're approaching that y value of 0 off to the right. Okay, so we may see things like y equals 3 times 7 to the x. In this case, 3 is our starting value, our y-intercept, and 7 is our multiplier. We might see functions that look like y equals 10 times 0.87 to the x. Here's our multiplier, that 0.87. And the big key in determining which of these two graphs that will look like is we look at our multiplier. And since in this case our multiplier was something greater than 1, our graph is going to look like this. In this case, our multiplier was something less than 1, and our graph will look like that. We won't ever deal with multipliers that are negative in this course. So actually, when I say less than 1, I mean something between 0 and 1. But here's kind of our general picture for what an the general form for an exponential function, along with what its graph might look like. We're going to do some examples in the next video. Okay,